welcome back to my channel. In my previous episode, we take a look at how to calculate using measuring instruments. I mean the vernier caliper and the micrometer screw gauge. In this episode, we are going to be looking at dimensional formula and dimension. This is another major area where JAMB question is centered under quantities. If you are new to my channel, please try to support my channel by clicking on the subscribe button and the like button to subscribe and like my video. Thanks. Let's get started. At the end of the class, we are going to look at this end of class question and see if we can solve that. Now, we have dimension. What is dimension? I don't want to go in depth into this. Dimension simply means the power of any fundamental quantity. The power of the basic fundamental quantity in a derived quantity. Are we together? That's what we call dimension itself. Now, you see, there are three different kind of variables, or let's say four different kind of variables. But I won't go in depth into them. We have what we call dimensional variable, the non-dimensional variables, the dimensional constants, the non-dimensional constants. I won't go into that for now. Now, what were we expected to understand under dimension in JAMB? All what you need to understand is how do you write the dimensional formula for different derived quantities. Let's say, for example, you see, if I have velocity, for instance, velocity, the dimensional formula of velocity can be written using its unit. That is the best way. The best thing is to convert that quantity into its derived unit. Then from its derived unit, you can find the dimensional formula. Now, in dimensional formulas is always written in terms of mass, length, and time in this order. Please note, in this order, M, N, and C. There are some quantities in which they contain length and time without mass. It simply shows that to find the quantity, mass is not needed. Let's take, for example, velocity is simply displacement over time taken. You know that displacement, please note something. When you are dealing with dimension, displacement and distance, they are the same. In vector, they are different quantities. Distance is a scalar, displacement is a vector quantity. But when we get to dimension, anything that can be measured as the unit of length are all lengths. Take for example, displacement in this case here is length. If I have distance, it is length. Radius, it is length. Diameter, it is length. Height, it is length. Altitude, it is length. Don't forget that as you know that altitude is a scalar quantity because it is length. Simply means height. Altitude is length. Breadth is length. Width is also length, etc. like that. Now, in this case here, I have displacement over time. My displacement is length over what? Time taken. In dimension, don't forget that my length is measured in meter and time is in seconds, which is meter per seconds. This thing is meter per seconds, mathematically. Now, if I want to write it in dimension, I know that meter should represent length, that is length. Time should represent seconds, that is t raised to power minus 1. So the dimension of velocity is mt raised to power minus 1. That is quite easy enough. What about energy density? Energy density. Let's take a look at energy density. What is dimension of energy density? Now, what I wrote here is dimensional formula. But the dimension itself, according to the definition, I said it is the power of any fundamental quantity in a derived quantity. Now, the basic fundamental quantity here, I've been able to express velocity in terms of length and time. Now, length and time are the basic fundamental quantity here. The dimension of length simply means the quantity of length that can be found in velocity is the power of that length in that quantity. The dimension of length in this place is 1 because length is carrying a power of 1. Dimension of time is -1. But what about mass? This quantity, as you can see, it does not contain mass. It simply shows that the dimension of mass in this quantity should be equal to 0. So here, the dimension of velocity should be equal to 0, 1, minus 1. 0, 1, minus 1. That is mass, length, and time. Mass, length, and time. Let's look at energy density. What is energy density? When I said energy density, density itself simply means per unit volume. Per unit volume. So if I said energy density, it simply means energy per unit volume. Just like say you have mass density, mass per unit volume. All together? So don't forget that energy is the same as work in formula. Because we know that what energy is the ability to do work. So I can write that energy density can be equal to energy over volume. And as you know that energy and work done by a body, they have the same derived units. So I can express energy in terms of work done. Since energy is work done is force times distance, that means energy will also be force times distance all over volume. Now, the unit of force is what? Kilogram. We've done that in our derived units. Please, you can visit that to understand more. Kilogram meter per second square. While the unit of distance is in meter. Now, volume is in meter cube. Why? Because volume is equal to length times breadth times height. Length is in meter, breadth is in meter, height is also in meter. So meter times meter will give me meter cube. So from there, I should be having something of this kind. Kilogram, meter times meter will give me meter square. If I remove 2 meters square from here, I'll be left with a single meter. Then I'll be left with kilogram per meter per second square. How do I get to this? This is per second square and the meter is below. So if this is 1, if I remove this and remove this, this is 1 over m. So 1 over m in indices is simply n raised to the power minus 1. You should understand that. So I should have something of this kind. From here, this one will simply give rise to kilogram per meter per second square. Now, in dimension, I've been able to express this in terms of the units, derived unit. Kilogram for mass, meter for length, seconds for time. So, energy density is now, the dimension for energy density is m, L minus 1, C raised to the power minus 2, which will give rise to what? 1, minus 1, and minus 2. This is dimension. This is dimensional formula of energy density. Please take note. We have dimensional formula. From the dimensional formula, we can get the dimension. That is how we solve it. Are we together? Now, let's now take a look at this kind of question that is given to us. This question is what? Taken from JAM. If they want to set question on dimension for you, they can ask it in this manner. Take a look at this. They said the value of x, y, and z, respectively in the expression mx, ly, tz for the universal gravitational constant g is what? What is the value of x, y, and z in this specific? If you want to get this value, the first question, permit me to rub up all this. The first question that we need to know there is that what is gravitational constant? That is what? Constant of universal gravity. We know that according to what? if I look at Newton's laws of universal gravitation, Newton's law said that it's what talking about what? The force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance apart. Now, I can easily make G squared formula from here. If I make G squared the formula, I'll be having FR squared over this times this times this, so mass squared. Don't forget I said in this case here, mass, there is no difference in mass, so all of them they are the same mass. So I can write this G. First thing I need to do is that express this G in terms of its derived units. Then from the derived units, you can now write it in terms of dimension, which is M, N, and T. Now, how did I express in terms of the derived units? What is the derived unit of force? Since force is mass times acceleration, the derived unit is kilogram meter per second squared. So, from this point here now, my force should be written as kilogram meter per second squared, and my distance should be written as meter squared. This is R. R is simply the distance apart, which is in meter squared. Now, everything over, this is my mass. This is mass. Mass is in kilogram, so here should be kilogram squared. Now, from here, I can calculate my G. Since we have G can move one G, I will left it to a single G. So, if I write this out, I'll be having 1 over kilogram is at the denominator, so I should be having kilogram raised to the minus 1. And meter times meter will give me meter cube and s raised to the minus 2. So from here, we can write dimensional formula. The dimensional formula will now be kilogram should represent mass. M raised to the minus 1. Meter is length. L raised to the 3. Time is seconds. T raised to the minus 2. So what will now be the dimension for gravitational, universal law of gravitational constant? From here, the dimension for this, that means the value of my x, y, and z should be, my x is for the mass, L is y, and this one is my z. So I should be having minus 1, 3, and minus 2, which gives us option B as our answer. So subsequent questions will be asked on this. We solve them in the same way. Don't get confused. 300 is the easiest thing to score in JAM. You just need to focus and understand the trick behind their questions. Thanks for watching this episode. Please don't forget to subscribe to my channel and also follow us to the end of the series. Thank you. See you in my next episode.